Hey everybody, what's up again? Distance learning continues. Last little bit of chapter 23 here. So this week we've looked at first how to kind of get how to do a t-interval, right? Like more like the application, right? Just conditions, math, right? Interpretation of your interval. We know that's for means. We looked at a little bit what the t-distribution itself actually is and how to find critical values and for a confidence level or a p-value from a t-score. And then yesterday we just looked at some problems finding margin of error and sample size. So today we want to wrap up with our old pal, the t-test. So let's jump in. Here we go. So today, get out of here, little icon. Today we want to, conduct that one sample t-test. We're talking stat tests number 2. So here's our context. Same as Monday, so you have this context written in your notes. If you don't, it's probably a good idea to pop it there, right? So same deal, randomly select 23 crows from some region. Sample mean X bar down here is our 4.9 parts per million. Remember, we're measuring the lead levels of the crows. There's our N, there's our X bar, and our SX is right here for our sample standard deviation. So our question today, some different biologist, different than the one originally referenced on the last slide there, thinks that lead levels greater than 5.5 should be classified as unhealthy. Read carefully. Lead levels less than 5.5, healthy. This is just that sample information I just referenced. And so our job today is, based on the sample data, is there statistical evidence to suggest, when we're taking the AP exam, that statistical evidence to suggest is some key wording that tells us we might use a hypothesis test. We want to know, is there statistical evidence to suggest that the mean lead level of crows in this region can be considered healthy, which means less than 5.5. Now, although we are going to approach this with a hypothesis test today, and that's, what I would do to answer this question, it is possible to answer this with a confidence interval. We did that in the first video, right? We went through the whole process, conditioned, math, interpret all that, but then we used our confidence interval to decide if we thought the true mean lead level of all crows in the region was less than 5.5. Now remember that 4.9, that's just the sample mean, just based on these 23 crows. So we can't just be like, yeah, 4.9 is less than 5.5, because we also know that if we took another sample of crows, we'd probably get a different sample mean. That's what sampling variability tells us. So this might just be less than 5.5 because of natural variation. We want to know if it's statistically significantly less than 5.5, and that's why we need our confidence interval, potentially, or what we're going to do today, our hypothesis test. So statistical evidence or statistical justification suggests we might do a t-test on our AP exam. If they gave us an alpha level that would be hopefully blatantly obvious, or a significance level, right? Those are the same. That was a t-test. So let's jump in, right? Process is the same ideas we've been working with. So hypotheses, conditions, math, conclusion. So the hypotheses. Hypotheses are always written as, right, based on some parameter and some value. So when we were talking about proportions in our last unit before distance learning happened and all that, right, this was always P equaled some number for our null hypothesis. By prop here, I mean like proportion or percentage. Now we're talking with means. So now we're not talking about the population percentage P. Now we want the population mean. What symbol? That's a weird way to ask a question, like point to my nose. What symbol represents a population mean? And hopefully you realize that that's now mu. That's a pretty bad mu. So like hypotheses, like the same ideas as always. Instead of P equals a number, it's going to be mu equals a number. Alternative hypothesis we know is based on the question. Instead of being P greater than, less than, not equal to some numbers, it's going to be mu greater than, less than, not equal to some number. So consider the question, right? Is there evidence that the mean lead level of crows in this region can be considered healthy? And write the hypotheses. Pause it, like that's what I was doing there with the pause. Right. And hopefully you wrote something like this. No big deal, right? And it's less than because healthy was less than 5.5 parts per million. No big deal. Moving on, conditions, same exact stuff as the t-interval. So these are just generic notes about the conditions, same as our interval video. So like it's literally the same exact conditions as the t-interval, with one prop Z, our null said P equaled a number, and then there was a P in the conditions. So the test interval conditions varied a little bit, differed a little bit. But for means, our null says mu equals a number, and mu is never used anywhere throughout the rest of our math. So for means, that null assumption is not going to affect anything. So the conditions are the exact same as what we saw in the T interval, a few days ago, right? Also known as this stuff. If you have a question, watch the first video about T intervals. We go to our math, right? If I'm doing that, popping everything in the calculator. So we're going stat tests. We're talking number 2 here, our t-test. Copy your calculator screen. Make sure you write down the name. Then we're just going to add the t-score formula. We also have to make sure we add the degrees of freedom. So take pause, right? And do that yourself right now. Do the math without me. So we're going stat tests. Again, we could put data or stats in. Here we got our mu naught. That's from our null. Our x bar, sxn, no big deal. Our alternatives less than. Color, who cares? It's for the draw. So we can draw our t distribution here, which does give us our t-score and our p-value. And just as soon as we see that p-value, hopefully we're already thinking about the conclusion. We go to calculate. This is the screen we're copying, right? So I personally like to copy all this stuff. And then we're going to add the formula for a t-score. So a t-score is calculated the same way as a z-score. So it's our sample statistic minus our population parameter. So our sample statistic, by the way, all the numbers you need are on this screen. Our sample statistic is our sample mean, 4.9. That's our x bar stat, minus the parameter is what we assumed in the null hypothesis. So I'll call it mu naught. That's our 5.5. And then on the bottom, that's our standard error formula, which is 1.12 over the square root of 23. And so I like copying this down because when I think about this T formula, like boom, 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 boom. There's all the numbers that we used in that formula, and that would give us the negative 2.569, negative 2.57-ish t-score. Make sure we label it as t equals, right? And now there's that. We looked at in our previous video, I could use a t-score to find the p-value using tcdf, but that's completely unnecessary because there's the p-value. Right, and we're going to use that to write our conclusion, which is all the same stuff as always. You don't need anything about that, right? So there's p-value. The one thing we also want to add is our degrees of freedom. So in this question, we want to add to our work that there are 22 degrees of freedom, and there's 2 ways you could do that. You could just list df equals 22, or we can write the degrees of freedom as a subscript with the t-score notation. All right, no big deal there. Really, really similar to what we did with our one prop z test. Next up, conclusion. Same deal as always. Compare the p-value to your alpha level. In this case, we weren't given one. Pick one of the common ones, 1, 5, or 10%, and hopefully you're thinking about why that doesn't really matter based on this p-value of 0.009. So write it up. You got that. And then hopefully you wrote something like this. P-value below whatever alpha level you're going to pick, so we reject the null. Right, so there is evidence that the mean lead level of crows in the region is less than 5.5. Or I could say the p-value is below any common alpha level, so we reject the null. There is evidence to suggest the mean level of crows is healthy or less than 5.5. So this is just showing 2 different ways that you might word this. Right, do whichever one you like more. From there, we're going to do all the same stuff. We're going to look at like what's a type 1 error, what's a type 2 error, power, whatever, all that kind of stuff, right? So type 1, in reality, the true mean lead level is 5.5, but our test suggests it's lower. So now we think the crows are all healthy when they're really not. We should probably help them out. Type 2 error, right? In reality, the mean lead level of crows is less than 5.5, right? Type 2 error, the second one is true. So in reality, the mean lead level is less than 5.5. The crows are healthy, but our test doesn't show us that. So then maybe we do some stuff to help the crows they didn't need. That's it. So practice and stuff. Practice posting in Google Classroom like always. And then we'll end with my sweet practice quote. And I'm clicking back over and over again. Hopefully you were like, dude, you're an idiot. And that's it. Practice, man. That's what it's all about. Peace, homies.